complex differentiation. So before that, what is complex number? Complex number is that combining the real and imaginary part. If it is a real part, so here that is x plus iy. So here x is a real part. Okay, and y is a imaginary part, and I is a imaginary unit. So in this I square is minus 1. So I is root of minus 1. You know the value I square equal to minus 1 and I equal to root of minus 1. Here the z value is defined as what is that? X plus iy. So what is z bar? Z bar is x minus iy. So if it is know the z value, we take the modulus, that is root of x square plus y square. Okay. So then what is the modulus of z square? So the modulus of z square is x square plus y square, then root of the whole square. Here the square root and the square values get cancelled. The answer is x square plus y square. So here f of s is equal to the w. Here the w is defined as u plus iv. Here the u is a real part and v is an imaginary part. This is the basic introduction of complex differentiation. Then we have to move on the analytic function. If it is an analytic function, in this analytic function f of z, it is a differentiable at a point z0. At a point z0, it not only differentiable the point z0, it is also differentiable to the neighborhood of the z0. That is differentiable with respect to z1, z2, etc. z. Okay, so it is a differentiable only the point z0. It is also differentiable the neighborhood point. That is called the analytic function. In the analytic function, it is a complex number. We have to satisfy the Cauchy-Riemann equation. If it is satisfying the Cauchy-Riemann equation, it is the analytic function. So what is the Cauchy-Riemann equation? So Cauchy-Riemann equation is nothing but ux equal to vy and uy equal to minus of vx. So if it is satisfies the CR equation, it is the analytic function. Okay. So here what is ux and what is uy, what is vx and vy. So you know some function u equal to what is that x plus iy. Then we have to split it. It is a real part and imaginary part. Then we have to find the ux, uy, then vx, vy. Then we have to check it is satisfying the Cauchy-Riemann equation. So it is called the analytic function. So in this next class we are going to see the analytic function basic problem. Then see the problem. Prove that w equal to z square is an analytic. So here w equal to z square, we have to prove that it is an analytic function. You know, if it is satisfying the CR equation, then the w equal to z square is an analytic function. So we have to prove that it is a CR equation. So w equal to z square. First we have to write what is w. W is nothing but u plus iv equal to what is z. Z value is x plus iy the whole square. Then we have to expanding this x plus iy the whole square using the a plus b whole square formula. That is a square plus b square plus 2ab. So here we have to x square, then y square. I square is nothing but the minus 1. So here we put minus y square plus 2xy into I. Okay, then we have to split this real part and the imaginary part. So u equal to x square minus y square, then v equal to 2xy. Then after that we have to find ux, uy, vx, vy. So ux is nothing but we have to differentiate with respect to x, that is 2x. Then uy, what is it uy? Yes, which is minus 2y. Then we have to find Vx equal to. So then we have to differentiate that is u, that is 2y. Then Vy equal to what is that? Yes, it is 2x. Then we have to combining ux, that is ux. What is ux? 2x. What is Vy? It is 2x. So here the Cauchy-Riemann condition ux, that is Vy is satisfying. So ux equal to Vy. Then we have to comparing the uy into Vx. So uy is minus 2y equal to 2y. So here see it is uy equal to minus Vx. So here uy equal to the minus Vx. So here in this problem it is satisfying the CR equation. So it is an analytic function. So in this analytic function it must necessarily we have to satisfy the CR equation. Thank you.